Okay, diving into Unit 4, we will start off with the introduction of 4-1, where we will cover certain terminology that we will use rather frequently when graphing sine and cosine functions. So here on the top left-hand corner, you will notice that we have two functions being given to us. One is y equals a times sine bx minus c plus d, and the other one is the same but written in terms of cosine. Now, what I do want you to notice is that in every single one of these, it looks like an alphabet, but the letters A, B, C, and D are going to be replaced with numbers in both equations, and those numbers are going to affect the graph and cause it to transform in certain manners, whether it causes it to move up, down, as far as vertical translation, left, right for horizontal, and then compression, reflections, stretches, all that kind of stuff that you guys have done with previous types of graphs. So we will start off first focusing on the a value in this function, and that a value there is going to be the coefficient of your sine and your cosine. That coefficient represents the amplitude, the AMP. All right, so if I ever ask you guys to find the amplitude, you are going to look to that number, that coefficient. All right, that coefficient, though, needs to be positive. Notice that I'm specifying right here that you must take the absolute value of the coefficient always. Therefore, amplitude will always have a numerical value that's always going to be greater than 0. It has to be positive, all right? So, for instance, if your A is -3, I need you to tell me amplitude is just 3. If the A value is 10, you will just tell me that the amplitude is 10. So in both instances, notice that your amplitude is a positive number, greater than 0. So that is amplitude, okay? Now, I will show you graphically what amplitude means a little further down when we look at certain graphs. Period. Period is going to be the length of the cycle, the wave pattern, okay? So we've covered amplitude over here in the chart and period. Period has a formula as well. And for sine and cosine, period is always going to be determined by taking 2 pi and dividing it by b. Now, b, if you look upstairs again, b is going to be the coefficient of your x, of your angle. Okay, b is going to be the coefficient of your x. So whatever that number is, you are going to substitute it in the denominator. 2 pi divided by b. And this function is for sine and cosine when finding period. When we move further down the road in the unit, you will notice that the formula for tangent is going to be different to determine their period. So period is 2 pi divided by b. Let's see. C, we're going to hold off on C for now. D is going to have to do with your vertical shift. So D, if you notice, is going to be the number to the far right. That usually is the number that is adding or subtracting at the end. And that's our vertical transformation, by the way. Just like, you remember when we used to do functions in Unit 2? The last number that was on the outside, the k value, that is our vertical transformation. So that right here has to do with vertical shift in our chart, okay? You are going to notice that I am going to ask you in the near future, right in like about a couple minutes, to find midline. Well, midline has to do with your D value. So whenever I talk to you about midline, you are going to look to see what is the vertical translation and you're going to look to that number, okay? So let's talk about midline. So down here, a little bit lower, you are going to see a graph, okay? And in this graph, there is a dashed line that we can see cuts our graph straight down the middle. That midline will always be a horizontal line. It will always be a horizontal line. Notice it crosses the y-axis. So this is my y-axis. It crosses the y-axis at the value of 1. So when you guys give me a midline equation, notice down here the answer is y equals 1. It will always be a horizontal line. And the format of your equation, because the line crosses the y-axis, is always going to be y equals some number. You will get it wrong in Delta Math if you do not write it in equation form. So for instance, if you just type in the little box a 1 as your answer, you're going to get it wrong. So make sure that you type y equals 1. Okay, so that's the midline equation. So let me give you an example of some midline equations. So right over here, let's look at this example. Okay, so determine the midline equation of this graph. So if we look at this graph, we are looking to be able to draw a line that cuts through this graph and splits it in half. Okay, so where can I draw that line? Well, if I drew this line right here, it obviously is not cutting the graph in half. How about right here? Well, it kind of looks like it is, but here's what I want you to notice. The distance from the midline to a minimum value, for the bottom part of a graph, and the distance from here to here, notice those distances, the pink, are not the same. Here we covered 2 blocks. Here we covered 1, 2, 3, 4 blocks. Those are not identical. So that's not the midline for sure. So make sure you eyeball it and make sure that you notice that the distance is equal. So that's not going to work. Maybe it's a little bit higher, maybe around right here. I'm thinking this is probably the line. So let's see. Is the distance from the max to here the same as from here to the minimum? It looks like it is. They both are 3 boxes. So when writing the equation, once I figure out what it is, okay, you will always write it in y equals form. So where did it cross? It crossed at y equals -1. So that's my answer for midline. Let's try another one. So look at this one. We need to cut this graph in half. So what are we going to do? Can you see it? All right, so I am going to draw this line. It looks like my midline. It looks like it's working out just fine, right? And I'm going to double check. Well, from the midline to this and the midline to the minimum, it looks like it's 1 block. So y equals, where is it crossing? It's crossing the 2. So there is the equation of my midline. Let's do it again. Let's draw a line. Let's draw it about right here. Let's see if that's correct. All right, so drawing a line from the midline to the maximum and from the midline to the minimum. Well, that didn't work, did it? No, because this one was 2 blocks. This is 3 blocks. So let's do that again. Let us bring it down a little bit lower. And let's see if that works this time. All right, so from midline here, that counted 3, 1, 2, 3. That looks better. So our answer for this equation for the green line is y equals, it crossed right here, 1. So equation of our midline is done. Okay, so that's how you find midline. So please notice again, they're telling you guys an equation. So make sure that there are equal signs in your answers, okay? Make sure there are equal signs. Okay, going back to, all right, so we're done with that page of your worksheet. Flip over your handout. Let's talk about period. All right, so period is the length of your wave. Now, your wave will start and end at a certain point, and these waves are going to go over and over again. The length of your wave is the length horizontally of your graph. That's the length of the wave, and that is called the period, okay? So in this particular problem, the length of your wave started at 0, and it ended right here at 4 pi over 3. That's why you said the period is 4 pi over 3, okay? Here they were telling us the amp is 1. Why? Well, the distance from the midline to the max and the midline to the minimum is going to be 1. So that's your amplitude. So amplitude is always going to be the distance from midline to max, midline to minimum, okay? So always measure from midline to the max and then to the min. Those have to be identical like we talked about in those previous problems. And again, notice always positive, okay? Make sure you always give me a positive number. All right. So let's practice some problems. So here's a problem. Let's determine the amplitude first. So if you look at this graph, what I need you guys to do is do exactly what you were doing before. Eyeball your midline, and then the distance from your midline to your minimum and max values, that's your amplitude. So whether you go midline to minimum or midline to maximum, whatever that is, when you are asked for amplitude, I want you guys to remember that you are only going to be giving me a positive value. So in Delta Math, they're just going to ask you to give amplitude, and then there's going to be a box, I think, if I'm not mistaken. And inside that box, just write the number. So in this case, our answer is just a positive 1. Do not write an equation or anything, just write a numerical value. So look at these two right here. Pause the video. I want you to find out what the amplitude is for this problem, okay? And I want you to find the amplitude for the bottom one. And then let's write our answers in these boxes. So go ahead and pause now. Okay, welcome back. So again, you are eyeballing the midline. The midline seems to be right here, if I'm not mistaken. And let us go ahead and draw some vertical lines from the midline to the max. So that looks like I can count 1, 2, 3, 4, 5. From here to here also looks like 1, 2, 3, 4, 5. So our amplitude indeed is going to be a positive 5. Down here, let's do it again. It seems the midline is about right here at y equals -2. So our amplitude ends up being, what is that? Is that 2? Yes, it is. This is also a 2. So 2 is our amplitude. Pretty simple, right? Okay. I believe this next slide, no, let me see if it's this one. Yes. All right, now the period. Remember, period had to do with the length of your wave, okay? But one cycle. So our wavelength here goes on forever in both directions, but I need you to just focus on one cycle. Again, midline is such a big thing when it comes to graphing sine and cosines. So again, visualize, here's our midline, okay? Now, what I need you to do is pick a starting point for your wave. And I suggest to students to always start your starting point from x equals 0. So right here at x equals 0, I want you to start your eyeballing from here. But that means that when you start looking at right there, I need you to go to your graph, okay? Now, your graph starts right here on the midline, okay? Here's where your graph starts. And it needs to complete one wave. So one wave, when it starts on a midline, see how your graph at x equals 0, so we're starting at x equals 0, let me make sure I mark here, at x equals 0. Our graph starts on the orange midline, and it's going to go up, and then it's going to go down, and then it has to come back up again and stop, okay? It stops right here, okay? So wherever it starts, that's where it needs to stop, okay? One wave, when it starts in the midline, goes up and goes down. Or it can also go, by the way, sometimes it can go down and then go up. Okay, so either one of those options works. So let me erase this. So how long is our wave? Well, our second dot ended at x equals what? At x equals 2 pi. So the length of our period, if you're looking at the length from start to finish, it went from here to here, okay? And from there to there, that gives us the length of our period, the horizontal distance. And that horizontal distance is 2 pi. So when I ask you for a period, this is the number for this problem. The value is 2 pi. The horizontal distance of one cycle. And if you look at it, it's 2 pi still over here as well, isn't it not? So if you trace the graph from here to here, that's going to be 2 pi, right? That length is still the same as the purple one that I did. So here's another one. Let's come over here. So let me get another color here. All right, where's our midline? So our midline is right here, okay? We are going to still start at x equals 0, at x, let me use a different color because that's not really showing up. Let's use red. So here's x equals 0. So we're starting right here. So I'm going to go to the graph at x equals 0, which is right here, okay? Oh, there we go. There's where that's not really working out too well, isn't it? Let me try that again. It's hard to draw on a graph. There we go. So there's where my blue graph started. I want to go back to the previous one to make it a point. Let me erase here a second. I want to show you guys to make sure you are not getting confused. Let me erase this a second. When I drew the midline here, I want you to notice that when I put my dot was on the blue graph and it started right here, okay? Notice the blue graph and my midline intersected, okay? And so that was my start, that was my ending, okay? And the graph went up and down. When your graph starts on the midline, that's known as your sine graph, okay? It's a sine graph. But I want you to notice the difference with this next graph. I'm going to go over. Notice this time the graph, okay, at x equals 0 starts above the midline. Therefore, when you trace this graph from start to end, okay, notice this time it is not going to be on the midline, okay? So it ends right here. It starts above the midline and ends above the midline. That one is called the cosine graph, okay? the cosine graph starts above the midline, all right? So that's how that graph would look. That's one cycle right there. You started at x equals 0, and where did it end? It ended at pi over 2. So our distance, horizontal distance from left to right, which is our period, is going to be a length of pi over 2. So when they ask you for period, you're going to have a box, and you're just going to type pi over 2, and you are done. Let's try one more. I think I have one more example here. Yep. Let's do our period, not a period, our midline. So there's our midline. Where does our blue graph start? Well, in this case, it is starting. Is it on the midline or above the midline? Well, at x equals 0, it's starting on the midline. So the graph is going to go up, and it's going to go down, and then it's going to go up again, and that's where it stops. So how long is my period going to be? Well, it started at, let's use another color, let's use purple. It started at 0, and it went all the way to right here. So that period length is how long? It is pi units long. So my period is equal to pi. Okay? And you could see it continue repeating over and over and over. So here's another period from here to there. Here was another period from here to here. So every single time you had a length from here to here, that's one. And this doesn't want to stick, doesn't want to work. But you know what I mean. From here to here was a period. From here to here is another period. So it keeps repeating, but I just need the distance of only one cycle. Okay, so that's how you do amp and period. All right, let us go to do the last thing. So let me go back to the front of our notes. Not there, right here. So go back to your paper, and the last bit is finding minimum and maximum value. So I'm talking about down here. You're going to notice that there is a formula, and the formula tells us to depend on the midline and the amplitude. So I'm going to box in here. So this formula is the next one you have to learn. Okay? Now, midline, remember midline in the previous page? Midline here is going to be our D value. All right? So when I come over here, midline is the D value in my formula, plus minus amplitude we know is our A value. So when I ask you to evaluate the maximum or the minimum of our graph, what you're going to do is look for the D value in your function. Well, the D value in my function, when I look at the equation here, so I'm looking at this equation right here, by the way, all right? My D value is the number that's adding and subtracting to my function. And in this case, my D value is going to be this number right here. That's my D value. So that's where this D equals -4 came from. My amplitude, A, is always going to be this number that's in front of your cosine or your sine. So my A value there is a -1, but remember when you guys give me amplitude, it always has to be positive. Always positive. Okay, so that's where you got the 1 from. So then notice when you are evaluating the minimum and maximum, all you do is substitute your values. So D minus A was -4 minus 1, which gave you -5, or -4 plus 1 that gave you -3. And you could see, here was your -3, that's your minimum. And here is your maximum. -5 is your minimum, and your maximum was -3. Okay? So let's look to a problem. Okay, so here we go. D plus or minus A is how you find minimum and maximums. So let me write that formula up here again. Your minimum, I think it's max first. Your maximum / minimum values are found by doing D plus minus A, okay? So first, identifying D and A is what you need to do. My D value in this problem is a 4. This is my D value. Write down whatever you see. My A value in this problem always has to be positive. It's always going to be in front of the sine or the cosine. It's already a positive number. So when I need to find my maximum, I'm going to do 4 plus my A. So in this case is 6. And for my minimum, I'm going to get 4 for my D minus my A. And it's a 4. So the highest point in my graph is going to be a 6. And the lowest value for Y is going to be a 4. All right, here are some other ones. Here, notice we need to identify A and D again. So here, that's my A value, but in this case, it is a negative number. So I need to make sure and tell myself that A is going to be 10, not -10. And then my D value, well, on the outside here, there aren't any D values. Notice your D value, there is a blank spot. There's nothing adding or subtracting in that space. So the D value in this case is going to be a 0. So when we do our minimum, we take our D value and we subtract our A value. So in this case, it's going to be 0 minus 10, which gives us a -10. For our max value, we take our D value and we add our A value. So in this case, it's going to be, put that back. It's going to be 0 plus our 10. So it's going to be a 10. In the next part here, this is our A value location, and this is our D value location. So in this case, our D, again, is blank, so it's 0, because there's nothing adding or subtracting. My A value has a -1, so I'm going to put a +1. So when it's blank, it's a 1 for A. So again, minimum, you start with D and subtract your A. So -1. For maximum, you start with your D and add your A. So the highest Y value and the lowest Y value is -1 and 1. Okay? Now, last but not least, let's go back to your page. Recall I told you guys that when given an equation, you are going to use the formula for period 2 pi over b. I know that's pretty small, but it's 2 pi over b, where b is the coefficient of your x. So sometimes you can't just look at a graph like we've been doing and look at the length of your period. Sometimes I'm going to give you an equation. So let's go do one of those type of problems. So here's an example. I'm giving you an equation of a sine function, and I'm asking you to determine the period. So now you don't have a graph to measure the length like you did in this previous problem. You could just eyeball it and say, oh, okay, from start to finish, it went from 0 to pi, and so my period is pi units long. But when I don't give you a visual, how do I do this, okay? And notice that I'm not going to want you to use a calculator to try and determine that. That would just be a nightmare, okay? So no calculator graphing or anything like that. So you are going to use the formula. So the formula to calculate period is 2 pi over your b. Now recall, your b is in front of x. The equation on the worksheet that you have in front of you was y equals, for instance, a cosine. You know what? Let's use sine since this problem is sine. A sine bx minus c plus d. Notice that your b value is right here in front of the x. Okay, so there we go. So we need to find our b value. Well, notice our b value is in front of the x. So here's my x, okay? And so inside this parentheses, I need to find my b value. My b value is always going to be the coefficient of x, okay? Coefficient of x. So anything that is with the x. So please note that your x has an invisible 1 in front of it and a 3. So in front of the x, the b value is 1/3. So when I ask you to calculate period, the formula says that we have to take 2 pi and divide it by b. I'm going to use a capital B to make it easier to see. So 2 pi divided by 1/3. Now what I want you to notice is you have actually 2 division lines, okay? Notice you have 2 pi divided by 1/3. So you have this division line and you also have this division line, okay? This is called a stacked fraction. And when you have a stacked fraction, you are going to rewrite it by multiplying by a reciprocal so that you do not have the stacked fraction. So what you will do is take the number that's above the first line, whatever that is. In this case, it's 2 pi. And then you are going to multiply by the reciprocal of the fraction below that first line. So the reciprocal of 1/3 is 3/1. And then you will just multiply 2 pi times 3 straight across, and you get 6 pi over, well, 1 just multiplying by itself down here. Let me do that again. There's just a 1, and 6 pi divided by 1 is just 6 pi. So the period length of this graph is 6 pi long. And you would just type that in the box, okay? There's no equation. Notice in the instructions up here, they didn't say equation. Let's try it again, okay? What is my b value? My b value is always the coefficient of x. So look at my x. My x is right here. And what is in front of my x? In front of my x is the 2. So b value is equal to 2. So when I go to calculate my period, the formula for sine is 2 pi over b. So it's going to be 2 pi over 2 pi, because b is 2 pi. Notice that our pi's are going to cancel to 1. 2 divided by 2 will also cancel. 2 divided by 2 is a 1. And that's how long our period is. One more time. What is our b value? It's in front of the x. So here's my x. What's around my x? What's the coefficient of x? It is 8/3. Okay. So, period is 2 pi over b. So it's going to be 2 pi over 8/3. So there's our two lines again. So when we have those two lines, you are going to multiply by the reciprocal. Notice in the previous problem, we didn't have two lines. So here I have to multiply by the reciprocal. So I take the top number and just write it down, and I multiply it by the reciprocal of downstairs number. And then I multiply horizontally. So that gives me 6 pi. Multiply horizontally. That gives me 8. But I know 6 and 8 can be reduced by a factor of 2. And there, my friends, is your period. And that is it. That's the lesson for today. So good luck with your homework.